Alright guys, hope you enjoyed your nice week off. We're going to do the notes that you guys had, that you got in your email real quick, so we can fly through them when we get back to school on Monday. Drop one of you guys on Monday, so on Tuesday. We're going to go through them real quick, so I hope you take the time to just sit and watch this video and fill in some of the notes. So we got the fundamental theorem of calculus, which you'll see written a lot in the notes as the FTC, fundamental theorem of calculus. One of the most important things we'll learn all year. It's all over the AP exam, so it's really important that you really understand what's going on here. It's going to be one of those things, you can't just memorize steps, you're going to have to understand it. Okay? There's two main parts to it, and the first part is still going to look very familiar. Okay, so the first part, basically right here, this is what we have been talking about and we've used for the past couple of weeks. Alright? If I want to find the area under a curve, I find the antiderivative, plug in the upper limit, plug in the lower limit, subtract them. This is the change in. Alright? So that's what we've been doing. Now we're just going to look at a way we can use this to find a particular point. Okay? Remember this right here? If big F prime equals little f, that means that big F is the antiderivative. Get used to that. You got to know that right away. Okay? And written down really note, we've already learned and used the idea many times in class. This theorem says if I want to find the area under the curve, I find the antiderivative, plug in the 2 points, subtract. Okay? So this is something we've already learned. Now let's see the new type of problem we're going to solve using this idea. There are 3 parts to this equation. Okay? I got the area under the curve. I got the value at this point and the value at this point of our antiderivative. Okay? Area under the curve, value at B, value at A. We can use this equation to solve at a particular point. So here's an example. If I tell you the area under the curve of little f from 0 to 3 is 12, the initial value of f, initial value that's at the point x equals 0, is 2, and we want to find big F of 3. Originally, before we learned this, we're doing this problem here, you guys would have to find the antiderivative, solve for C using this point, F of 0 is 2. You have to use that point, solve for C, and get an equation. This is another way to do the same type of problem without solving for C. Okay? So these are basically the things I know. I know the area under the curve is 12. I know that F of 3 is 14. So we got 12 equals 4. Oh, oops. We got right here 12. F of 3 minus 2. We know that F of 0 was 2. Plugging them in on all these pieces. This is my 12. This is my 2. That's what I'm solving for. Basic algebra that we figure out that at that point, big F of 3 is 14. Okay? Again, the other way we would do this, we'd have to find the antiderivative, solve for C, and then we can figure out that point. Okay? But we don't have an equation here, so we can't find the antiderivative. This method is helpful when you can't find the antiderivative. Use ideas from the last page of your calculator to solve the following problem. Okay? This is a function where we cannot find the antiderivative of that. Okay? Normally you might think, okay, I'll do u substitution. U substitution would not work. Okay? Because when we find the derivative of the bottom, that's just going to be 3. That's not going to cancel x squared. Alright? So u substitution won't work. We cannot find the antiderivative. It is not possible to find the antiderivative. So we're going to use our calculator, and we're going to use what we know is true. This statement from the first fundamental theorem of calculus is true. The area under the curve from A to B, let's see, we're using points 0 and 10. From 0 to 10 would be equal to the antiderivative at 10 minus the antiderivative at 0. Okay, that's a true statement. Alright, now let's just fill in what we know. We know that the curve we're talking about from 0 to 10 is x squared over 3x plus 6. We know that f of 10 is, we don't know f of 10, that's what we're looking for. We know that f of 0 is 3. We can find the area of the curve using our calculator. Okay? Using our calculator. What is it? I don't know. I gotta get my calculator. Alright, take your calculator. Hopefully remember how to do this. Graph this equation right here. Go to second calc. I think it's number 7, the one that has the little integral sign. Plug in 0, enter, 10, enter, and you get the area under this curve is 12.389. Alright, so now all we have to do is simple math, add 3, and we get big F of 10. The antiderivative at 10 is 12 plus 3, 15.389. Okay. So this is a very common multiple choice type of question you'll see on the AP exam. Alright, same idea, next page. Alright. The hard part for these type of problems is recognizing what you're supposed to be able to do. This one's a little bit fuzzier, this one's a little bit harder to recognize that you're supposed to use the fundamental theorem of calculus part 1. Alright, big F is the antiderivative. I have the graph of little f. I want to figure out what big F of 0 is. So you should start getting used to seeing this. If I see two big F's, or two antiderivatives, and the original, the derivative, okay, two big F's, one little f, that's the first fundamental theorem of calculus. So we're going to use this exact same idea. From A to B, my A and B are 0 and 2. So we know that this is a true statement. The area under the curve from 0 to 2 is the antiderivative at 2 minus the antiderivative at 0. Okay, let's plug in what we know. Well, we know f of 2, big F of 2 is 7. Big F of 0 is what we're trying to solve for. Area under the curve, this is a basic geometric area. Right? You guys had a problem like this, multiple choice, midterm. It was on the midterm you guys didn't know how to do yet. It looked just like this. Okay, we can find the area under this triangle. We got 2, 1, 2, 3, 4. 4 times 2 divided by 2 because it's a triangle. 4 times 2 divided by 2 is 4. So the area under that curve is 4. Alright, now we're just going to do basic algebra, solve this. Alright, we're going to subtract 7 both sides. I get -3 equals negative f of 0 as the computer decides to update. Alright, there you go. So that means f of 0 was 3. Okay, so here's one where this would be non-calculator. You find the area under the curve by using geometry, and you're using the fundamental theorem of calculus, that first part. Alright? Okay, so again, you have to recognize that it's basic just plugging in. Writing what you know is true. We knew that this was true, and filling in what we know.